Hello, everyone. So, as mentioned, my name is Tania. I come from Melbourne, Australia. I'm a senior Apple sysadmin at Seek API, and I'm here to talk to you about a Slack app that I created specifically with the level 1 and level 2 techs in mind, trying to help them better support the Macs in our fleet. I'm going to start off with explaining what problem I was trying to solve when I was thinking about creating this app. Then I'm going to go through how /Jamf works and then the components that I used to build it. And then I'm going to talk a little bit about the offspring of /Jamf, which is called MyMac, or /MyMac, which is a customer-facing equivalent. And then I'll wrap it up with just a few gotchas and things that kind of kept me up at night and really tripped me up. So let's begin. I started working at Seek about 2.5 years ago. I was initially in charge of managing the fleet of 350 Macs across 5 locations in Australia and New Zealand. Over the years, Seek has acquired a few business, volunteering and education businesses around the world. And about a year ago, or a little bit more than a year ago, it was announced that it would combine into a single global entity called Seek API, Asia Pacific and Americas. And this was going to combine the Seek Asia colleagues as well as the CATHO in Brazil and OCC Mundial in Mexico. So the first phase of the Seek API rollout involved working with our Seek Asia colleagues in sharing resources and experience and infrastructure. And so it was just really good timing that at the same time that this was happening, they were looking to finally manage their 180 Macs. So they've got the Macs were spread across 6 locations in 5 countries in a completely unmanaged state. And so they were looking at using Jamf Pro. So that's where I came in and stepped in to help them in a sort of phased approach, migrating these Macs from completely unmanaged to managed. The Macs are only about 12% of their fleet. So what this meant was that the level 1 and level 2 techs didn't really get much of an opportunity to get that macOS support experience. And it also meant that, that there weren't really that much training opportunity for them either. So pretty early on, one of the main challenges that I identified was how can I best help these level 1 and level 2 techs across multiple locations, different time zones, with varying levels of experience, best support the Mac fleet in this state of flux, right, as we gradually migrated them across. And it's all about just being able to support the Macs in an effective and efficient way. So that was my challenge. So I thought, great, it's going to be easy. I'm going to give them read-only access to the Jamf Pro Console. I'm going to create some Seek Asia specific extension attributes, smart groups. I'm going to document the hell out of everything, and it's going to be a raging success. But this optimism was short-lived as soon as I logged into the Jamf Pro Console. And then I realised that my task was going to be having to highlight attributes in a sea of attributes with multiple things to consider, qualifying what is considered a good value and what isn't. And there's a lot there, right? So what's considered a good last inventory update date, last check-in, so on and so forth. There's a lot there. The Jamf Pro Console, it's busy and it's really not intuitive for a beginner. The UI doesn't translate well to mobile, and as we know, a lot of level 1 and level 2 techs, what they're doing is they're doing desk visits, they're having to troubleshoot at someone's desk. It's not really something you can't really get them to look at the Jamf Pro Console on their phone. You can't be assuming that everyone's carrying their laptop around at all times. So, and in addition, I'm expecting them to remember exactly what attributes to look at when they're logging into the Jamf Pro Console. So The reason that it's such a big deal, the fact that the Jamf Pro Console experience is not really feasible for these beginner macOS techs, is that there's just so much useful information that Jamf Pro captures about these machines. And if you're going to be troubleshooting something, if you find out what these additional attributes are, it gives you an opportunity to also provide some proactive support. So, as an example, you get a ticket because a user cannot print from their Mac. You fix that, but at the same time, you go into the Jamf Pro Console and notice that it hasn't actually checked in or done a recon in quite some time. So that means that there's something wrong with the Jamf enrollment of that machine. So you fix it, you just re-enroll the machine there and then. Great. In that process, you realise that there's a substantial number of 32-bit apps and that the user's planning to upgrade to Catalina and that it's going to be a problem, so that starts a conversation. And therefore, one ticket, which started with the printing issue, is also an opportunity to resolve a number of future support tickets. So I realised early on that the Jamf Pro API was going to be my friend. It gives me an opportunity to pick and choose what attributes I want the tech to see. And I have a lot more flexibility at that point to decide how I'm going to present this information. So the next question for me was how am I going to present it to the tech? I initially considered creating an iOS app. In fact, I went ahead and created one, and it was really difficult it was a lot of work, and I realised early on that it was going to be something really difficult to be updating on the fly. And I was also going to be forcing these techs to be carrying around an iOS app, which is also not really sustainable or practical. So Slack came to mind as the obvious solution early on. In Australia and New Zealand, we've been using Slack for a few years now. It's the main way that we communicate with our customers and the way that they communicate with us. And we also use it to communicate with our Seek Asia colleagues. The Slack API documentation is really good, it's clear, it's easy to use. And so it became clear pretty early on that a / command specifically was what I was after. So let's step through how /Jamf works. It's a Slack / command. What that means is that it's initiated from the message input field in Slack. It's invoked by entering a / character and then followed by the command name. The user can provide some parameter values, and then that data, it's a post request that gets sent to your web app. The payload that Slack sends to your web app is in URL encoded format, and Slack's going to expect a response within 3 seconds. If it doesn't get a status code 200 back from your web app within the 3 seconds, it's going to assume that there's something wrong, and it's just going to present to the user a timeout error, and then that's the end of that. So within 3 seconds, and any text that your web app sends to Slack is going to be by default ephemeral. I'm probably pronouncing it incorrectly. What that means is that if it's only visible to the user that invoked the app, even if it was invoked on a public channel. So it's private message. So here we are invoking /Jamf and we're providing a parameter value of Tania computer followed by an asterisk. This is the equivalent of doing an advanced computer search in the Jamf Pro Console. So I'm looking for any computers that match the word Tania computer followed by any sequence of characters after. What I'm going to get back is any matching computers. In this case, there's only one that matches. And I'm going to have a more info button corresponding to each matching computer. So when that more info button is clicked, then you get back a health summary for that particular machine. And so what I'm including in this health summary is a list of all the important stuff that Jamf collects that I want them to consider. I want specifically the level 1 and level 2 techs to consider when they're troubleshooting a Mac. So this is an example of the app in action. So as you can see, you get the first thing you get is like a verification that something's happening behind the scenes. The user clicks that more info button, and then health summary is presented. As you can see, it's easy to use, very little training required for the techs in preparation. All the important Mac attributes are efficiently listed. They don't have to be clicking through multiple panels on the Jamf Pro Console. And it's a really quick assessment of Mac health through the power of emoji. I guess I just want to drive that point home a little. If you have a look at this one, this health summary, the half a second, quarter of a second that it takes your brain to process all those warning emojis, that's enough for you to realise that this Mac requires some additional investigation, requires a little bit more effort. Coming to that same conclusion from the Jamf Pro Console requires a lot more time, a lot more experience, and a lot more brain power. So let's go through how the app is made. I'm using 3 main components, which is AWS, which is where my web app lives, the Slack API, which is how I'm interacting with the tech, and the Jamf Pro API, which is how I'm extracting the values that I want to present. So with the AWS services, there are 3 main services that I'm using. Lambda is where running the code. API Gateway is giving me that URL so that Slack can send the payload to my code, and SNS. So Lambda is a serverless compute service, which means that you can run code without having to worry about a server running it. It natively supports all those languages, but there's also a runtime API, which means that you can pretty much run any language you're comfortable with. That's the spiel on what API Gateway is. But what it comes down to is that it gives your Lambda function a URL so that Slack can interact with it, so it can send the data to it, the post request to it. Considering all the things that my Lambda function has to do, it has to respond to a status code of 200 within 3 seconds, it has to make that Jamf Pro API GET request, it has to loop through the results and format it and send it to Slack. That's a lot for it to do. So it does make sense to split the tasks into 2 Lambda functions. So the first one's going to do the respond with the status code of 200, which it needs to do within 3 seconds. So then the challenge is, how does that second Lambda function that has to do all the grunt work, how does it know what it needs to do? And SNS is the solution that I've used. So simple notification service, it's a push messaging service. An SNS topic is called, instance is called a topic. And so it allows that first Lambda function to notify the second Lambda function that it's been invoked. It allows it to give that second Lambda function the JSON payload so that that function knows what the search string is, where it was invoked from, who, what, where, etc. So here we go, we've got the first function that's going to publish to the SNS topic, and then the second function is going to subscribe to that SNS topic, and as a result, as soon as that SNS topic is published, the second Lambda function kicks into gear and grabs the JSON payload and starts doing all the work that it needs to do. That covers the main AWS services that I've used. Just wanted to sort of briefly go over identity and access management. Traditionally, you think of access as being access to a user or a group, but AWS uses sort of role-based access management. What that means is that you create a role that has the right to execute your Lambda function. That role, best practice is for that role to then have explicit rights to use the services that Lambda function is using. So not anyone can publish to that SNS topic, for example. only the role that's been given the execution rights to that Lambda function can publish to the topic and can subscribe to the topic. So it kind of just makes it nice and secure, fairly sandboxed. On the Slack side of things, everything's like super easy. It's about 4 steps. You go ahead and you give your app a name. Then you give your command name. It's possible for there to be 2 slash commands with the same command name in the one workspace, and Slack is only going to show the one that was most recently created. So just make sure that the command that you use is fairly specific, not too vague, just to minimize the chances of someone else in your workspace in the future clobbering the one that you've created. So the most important part is defining what that request URL is. So when that command is invoked, where does it send the payload to? Then the next step is that we're going to enable interactivity. The interactive component that we're using, because there are many that a Slack app can use, is the button. So that's the interactive component. All you have to do is toggle it on, and then you have to define the request URL for that button. So that means when the button is clicked, where does Slack send that payload to? You could, in theory, use the same request URL for both the slash command and the button, but then your Lambda function has to figure out, okay, where's this, who am I being invoked by, a button click or a slash command? And also the payload is considerably different. So for that reason, it's just much better to have 2 separate Lambda functions and 2 separate URLs. I think anyone that uses Slack here would be fairly familiar with the basic formatting rules for Slack. So text that's bookended by asterisk is going to be bold, by underscore is going to be in italic, and you can have a whole chunk of text sort of as a quote, which means indented and then with a bar to the side, using the angle bracket, the greater than angle bracket, and emojis are bookended by colons, and the backtick is a way to insert code, or also Slack formatting characters without it being formatted by Slack. You can also add hypertext in Slack. You can't do this if you write directly into the message box, but you can if you're presenting the text via API. So in this example, the About SIP is actually going to link to an Apple knowledge base article that talks about what system integrity protection is all about. And the way you do that is you just have, it's bookended by the angle brackets, and on the left you've got the link, and on the right you've got the hypertext. When it comes to configuring the Jamf Pro side of things, the biggest task was identifying what kind of attributes I wanted to present. Last check-in and last inventory update, definitely important. Hardware warranty information, definitely important. But realised pretty early on that I'm going to be relying a lot on extension attributes to be sort of doing the logic that was necessary. So in terms of actually accessing this information, pretty straightforward if anyone has experience using the Jamf Pro Classic API. The request URL that I'm using is the match. So this is the equivalent of doing an advanced search in the Jamf Pro Console. And what I'm going to get back is a whole bunch of information. And then following this, once the user clicks the button, I know what the computer ID is that I'm interested in, and I'm going to use that computer ID to do another request for all the information for that particular computer. Other things that are pretty important to consider when I was building this were, did I care about the order in which the results were presented? And what method could I use to step around that? Another thing to consider is if I'm relying a lot on extension attributes, I don't want to be doubling up, because you don't want a recon that takes 2 minutes. Like you really want to be efficient with the way that you use your extension attributes. So that was something that I had to consider on early on. The other thing is sustainability. If I no longer work at Seek, I want to make sure that that doesn't mean that the app no longer gets used. It's the way that I've made it as sustainable as possible is by making sure that all the formatting and the logic sits in the JAF Pro Console, and so it doesn't rely on the next Apple sysadmin having to know their way around AWS or having to know Python. So I'll show you in a little while how I made that happen. And then the other thing is having a think about what emojis you're going to use and how you're going to format it so it's nice and clear. So this is an example of the extension attribute code. So as you can see there, I'm having a look to find out what the SIP status is for that machine. And then it turns out that you can have emojis in your extension attribute output. So then based on the result of that lookup, I'm defining what emoji I'm going to present. So there it is in the JAF Pro Consoles. And this is what it looks like for a particular machine. So you can clearly see the emoji translates well. So for the person using the JAF Pro Console, it's still readable. On the Slack app side, for the health summary, it's also very clear. And as you can see, because the output has the angle bracket, it's presented as, on the Lambda function side of things, I format it so that the value is formatted in quote, as a quote block of text. So it's indented and has the bar to the left. You can't have emojis in extension attribute names, but you can have Slack formatted emoji names. And so I wanted to have the lock icon to be presented in the next to the name of the extension attribute in the health summary. So that's how you do that there. So on the Lambda function side of things, what I'm doing is I'm grabbing all the extension attributes that the computer has, I'm looping through each one, and I'm looking for the word Jamf hyphen. If it exists in the extension name, then that means that it's something that I want to present in the health summary. Then I do a whole bunch of formatting changes so that it gets shifted to the right and so that it looks good. And then I append it to the one string, which is what's getting sent back to Slack to present in the health summary. Group membership, so smart group and static group membership is also important, and I use a similar method in that I'm grabbing all the groups that the computer is a member of, and then I'm looping through and I'm looking for an emoji. So in this case, I'm looking for the warning emoji in the smart group name. If it's got the warning emoji, then that means that I want it to be presented in the health summary, and I'm just going to append the word member of to the start of that so that it's very clear that in the health summary that this is about group membership information. So hopefully it's clear that this is a sustainable approach in that any future tech, if they wanted to remove a particular attribute from the health summary, they don't need to go into the Lambda code. They just make the change. They just remove Jamf hyphen from the extension attribute name, and it's going to immediately result in it no longer being in the health summary. And if they wanted to add a new attribute, all they have to do is add Jamf hyphen, and it'll be added. So those are the three components that make the Slack app. And so now we're just going to step through and see how they interact together. So first things first, /Jamf is invoked with the search string of Tania computer asterisk. And that means that Slack is going to send some URL encoded text payload to API gateway, which then forwards it on to our Lambda function. That Lambda function is going to send a status code 200 to Slack, and it's going to send the payload that Slack gave to the SNS topic, which, so this is that first Lambda function. It's because it receives it in URL encoded format, it uses the URL parse module to convert it. And this is the block of code that I'm using to publish to that SNS topic. Bodo 3 is the module that you use to interact with AWS Services. And here, I'm grabbing the search string, and I'm just appending to the asterisks, any asterisks that I find, a Unicode character called combining grapheme joiner, which is a really ugly name for a character. What it does is it just means that Slack is going to not think that we're trying to format bold text. We want it to just display it as an asterisk. And by appending that particular character, Slack ignores, its own formatting rules. So then we're returning a response text to the user to let them know that stuff is happening and the status code of 200. So at that point, the SNS topic is subscribed to by our second Lambda function. It's going to grab the JSON data, which is then going to extract the payload that Slack sent through. As you can see, extracting it from an SNS topic just means that it's kind of embedded a few levels in. And the important things that it's going to grab is the response URL, which is where does it send the response, how does it contact Slack, which channel did it come from, and what was the search string. So the function at this point knows what search string to use for the GET request. So it sends it through to Jamf Pro. And that's just how that GET request gets done. And Jamf responds with a whole bunch of JSON data. From the result, our function is going to find out how many computers match that search string. And then it's going to loop through each computer and create an attachment array. I'm not going to go into how to create the response for Slack. That's like a whole nother session. But I will be providing this example code so that you can build your own on my website. So here you go. Each attachment object is information about the computer that it's found, and it also provides a little button for that particular computer. And as you can see there, hopefully you can see that the button value is the computer ID. So then it uses the response URL to send through the main text, which is, this is the number of computers that I found using your search string. And then these are the array of attachments that we've created. And that's just the block of code to just to post it back to Slack. When the More Info button is clicked, the workflow is pretty similar. Slack sends some URL encoded data to your Lambda function. This is your third Lambda function, which in turn responds with a status code of 200 again, and then also publishes to a second SNS topic. That second SNS topic triggers our fourth Lambda function, which now has the computer ID that we're interested in. So then it's another GET request to Jamf Pro. Jamf returns the results. And we do a little bit of formatting with the results, and then we send that to Slack, and the health summary is presented. So securing the app is pretty important, considering the kind of information that Jamf Pro has access to. So I did that in 4 ways. Number one, I'm verifying the channel ID. So I only want the / command to work if it's being run from a private tech-only Slack channel. Number two, I'm locking down Jamf Pro permissions. So that means that the username and password that I'm using to do those Jamf Pro GET requests has only limited rights. I'm verifying the message is actually coming from Slack, and I'm not hard coding any sensitive information in the Lambda code. I'm accessing it on the fly. So just very quickly, because I'm doing okay for time. So here I'm identifying the channel ID that I'm expecting, and I'm grabbing the channel ID where the request is coming from. And if it doesn't match, then I'm going to return to Slack a message just letting them know that, sorry, you're not invoking this command from the authorized channel. For Jamf Pro, the Jamf Pro username and password that I'm using for the GET request, all it needs to have is read access to the computer object and nothing else. Next, I'm verifying the Slack signing secret. So when you create an app, you get a Slack signing secret, which is there. It's only visible via the Slack API console. And you use that string to create a hash value of the request that you've received, the timestamp, then you add v0 equals at the start as well. You create a hash value that uses that signing secret as a base, and then you compare that to the hash value that's been delivered in the header of the request. So here's the code that makes it happen. So I'm grabbing the timestamp, I'm grabbing the request body, I'm creating that base string, and then I'm creating a hash value using that base string and also the signing secret that I know from the Slack API console. Then I'm grabbing what the signing secret that's been delivered from in the request header, and then I'm comparing it. And if it doesn't match, I actually send back to Slack the status code of 412, which I think just means precondition failed. The other thing that I'm verifying is the timestamp, just making sure that this message hasn't been sent more than 5 minutes ago. So once again, just sending back a status code of 412 if the message is too old. So another AWS resource that I use is Secrets Manager. I'm storing the sensitive information, which is the Slack signing secret, the Jamf API credentials, channel ID, anything that you really don't want to be hard coding into your function. And then within my function, I'm retrieving those values on the fly. So pretty straightforward. In the Secrets Manager, you create a secret and you define your username and password as an example. And in your Lambda function, what you're doing is you're running a function called getSecret, which Secrets Manager actually provides for you. It's super helpful. It just gives you like a Node. Node.js, Python, and maybe Ruby examples of exactly what that getSecret function is going to look like so that it can retrieve the username and password, in this case, for your Jamf Pro API call. Okay, so as a result of the success of /Jamf, I created something that would be customer-facing, which is my Mac. So it's invoked using /myMac. No other parameter values are required. I'm just simply grabbing the Slack username and using that as my search string. And because it's customer-facing, the language that you use has to be less technical and a lot more informative. And so I include links to Apple knowledge base articles, and I also include links to self-service policies. So this is an example of my Mac in action. And the user clicks health summary, and then the result is there. What you're able to see there is that you can a clickable link is to reinstall a component. So now they've clicked to reinstall Nomad, and then that opens up self-service and starts straight away executing the policy. The way that I did the links was what this meant is that I made the change on the extension attribute side of things. So here I am again looking at what the SIP status is for a machine, and based on what the result is, I'm providing a different emoji, providing different instructions on what to do, and for both of them, I'm providing a link to more information about what system integrity protection is. So I'm just going to go through, just to wrap it up, the kind of things that I guess tripped me up along the way. First of all, Jamf records the epoch time in milliseconds. So just remember that if you're wanting to know what the difference, like how long ago the last inventory update was, just remember that Python time module is in seconds, and so you're just going to do some sort of conversion to be able to subtract. The Lambda function by default times out after 3 seconds, which is usually a good enough amount of time. You don't really want to have a function that lasts longer than that. But the two functions that are doing all that grunt work, they tend to, I have found that they, depending on the internet connection between your Lambda function and your Jamf server, that you need about 3 to 6 seconds. So just remember that to increase the timeout. Slack only allows 100 attachments per message, and they also suggest that you really limit it to 20. So in my code, I've got that if that search string results in more than 20 computers that match, I send a message back to the user saying your search string isn't specific enough. The response URL, which is how the Lambda function knows how to communicate back to Slack, can only be used up to 5 times within 30 minutes, so just take that into account. And also just remember to provide a helper text for the / commands. What that means is that if you want to make sure that you check to see if there actually is a parameter value or a search string when the /Jamf is being invoked, and if there isn't, or if the search string is the word help, then you want to respond with some helper text. This is an example of what I send back if those conditions are met, which is just like a summary of how to use the app. I guess just be aware that I used AWS because that's what they use in my organisation, and I was also super interested in learning more about it. But you can use any serverless compute service out there. There's Heroku and Azure and Google Cloud. And also I used Slack because that's the main tool that we use to communicate, and it's got a great API. But anything that has some sort of API can be used. And you could even create an iOS app if you so desire. This is just a retroactive disclaimer that this is all just I just sort of fumbled my way through this, just like I fumbled my way through this presentation. So just I'm more than happy to talk about the code that I have presented, or anything else about /Jamf or /mymac, and I can be contacted via those 2 means. Thank you very much.